Hi, I'm Keith Oglesby. It's great to share with you a few moments today about quantitative methods of research. Our group is composed of Marie Felix Paul, myself, Keith Oglesby, and Jason Patterson. You know, when we think about research, I don't know about you guys, but sometimes it seems super overwhelming. I think of many times, like early on when I would vacation, when you would go snorkeling. And when you would be out snorkeling, you would see fish and see coral, but many times it would only be waist deep. You could just stand up. You were comfortable. You could look around. You could watch your children. But then, as you got better and became a more accomplished snorkeler, you would go all the way underwater, and you learned how to come up and blow all of that water completely out of your snorkel. Well, then if you wanted to advance and go beyond just corals and the beautiful fluorescent colors of all the fish, you could go deep sea scuba diving. Well, today we're going to snorkel for most of our presentation today, but then when we actually talk about research designs, the quantitative method 5 designs, we're going to go deeper and deep dive. I don't know about you guys, but sometimes word pictures really help me. And as I've thought about quantitative, I always think about quantitative versus qualitative. For me personally, it always helps when you can relate new information to something that you already know. Now in research, we know we call this compare and contrast. When we compare and contrast the differences in qualitative and quantitative research methods, we learn that quantitative studies, what we will be focusing our attention on here today, are studies that generate numbers. In fact, numbers derived from questionnaires, tests, or experiments. Now, this is important because quantitative methods are looking at formulas. They're looking at scientific ways to verify information. In fact, it could be a research or social experiment, but it's looked at through the lens of quantifiable or quantitative research statistics, either past statistics, historical statistics, or maybe future studies. Now, qualitative, on the other hand, which is assigned to the other group, it generates words instead of numbers. In fact, words that describe people, people's actions, their behaviors, and their interactions together. So when we talk about research methods, are we looking at the science and the scientific, and are we looking at the numbers? Or are we looking at observations of people, words, descriptors, both very important in our field of research? Being a word picture thing, I kind of talked about a word picture thing. I'm not nervous. I'm just trying to get through it all in 20 minutes. But word pictures for me always really help me personally understand. And in the Olympic year of 2020, when you talk about quantitative versus qualitative, I found these to kind of give us a word picture, if you will. Quantitative studies are measurable. In other words, this is the 200-meter final in the last Olympics. We know that this is 2020 Olympic year in Tokyo. And in a qualitative study, all of these runners begin at the exact same time. All of these runners will also finish 200 meters in. We can tell in each lane how long it took each participant to cover that distance. And we know it exactly. In fact, we know it through a laser, the moment, because sometimes the difference between a gold, a silver, and a bronze might be a fraction of a second. Quantitative studies show us those differences, the scientific difference in what each different person measured for that distance. We see that also in an event like swimming, when we see the swimming of Michael Phelps, who, as we know, won more gold medals at that time. Of course, Simone Biles will surpass that this year. But quantitative studies, they have to hit the pad. They're swimming, they hit. They can quantify when the race started and when it ended. That's the way quantitative studies work as we are proving them. What's also great is you can compare, whether it is in something like track and field or swimming, to past historical events. We could say the world record holder from 1988 did it in this exact measurable scientific time. compared to Michael Phelps, who just swam 30 minutes ago and either exceeded that time, beat that time, or didn't quite set a new world record. Now, qualitative, not what we're studying today, but just in comparison, qualitative are different. They are studying people. They are people's observations of skills. Here we have another Olympic sport. Good friend of ours, Simone Biles. My daughter trained with her for 9 years. In gymnastics, there's a code, and if you do a certain skill, you are awarded points for completion of that skill. However, there is an interpreter's opinion about how well you completed that skill. Was it with a little bobble? Was it with a step? Did you in any way step off what was expected? And everyone subjectively has an opinion about someone's ability to perform a skill. So what was the quality of that skill? Not just quantity, was it actually completed, but to what level or degree? Gymnastics is a great example of that. Also in our Olympic sports, diving is the same. You perform a dive, it has a level of difficulty, but 8 judges all have an opinion about that dive. And they throw out the high score and the low score and average the other people's observation, the other people's opinion about the completion of that skill. So quantitative and qualitative, as we see, are very different. Now, we're not covering mixed messages in our 2 assignments, but I just threw this up quickly. Mixed methods of research combined. And baseball is a great example of that. There are quantitative objectives. There are 3 outs when you're at bat, 3 outs for the other team. There are 9 innings in a game. If you hit the ball, you have to run to first base, then second base, then third base. So there are quantifiable, how many runs did you score? How many pitches did you get? You get 3 strikes and you're out, or 4 balls and you walk. Quantifiable, objective measurements. Yet what makes baseball mixed messages is that you have an umpire behind home plate. And a ball and a strike is a subjective measurement. Some umpires have a wider strike zone. Some have a very narrow strike zone. So within the quantifiable number of outs, number of innings, you have an interpreter of a skill of the baseball coming at you. One person's opinion, it was a ball or a strike. Those are called mixed method research observations. So the rest of our time we'll be looking at the differences in quantitative and qualitative. So let's start now. Okay? I have a summary chart. I know this is kind of a big chart. It's a lot to take in, but it's a good side-by-side comparison to help us understand the different types of designs. And then we will finish looking at quantitative 5 methods. For this chart, we can see that quantitative, here when you're looking at this on your left, they are experimental designs. We'll be talking more about. You're manipulating variables to see the impact of one variable on the outcome of the research or the study. Whereas qualitative are naturalistic. You're actually learning how to make observations and interpret what is going on by watching and seeing natural interactions among people. Not as scientifically driven, but more observation driven. We can see that quantitative are explanatory. They explain a theory or a phenomenon, whereas qualitative, by and large, are more descriptive. What is actually happening? What is going on? Third, there is a deductive analysis. Quantitative either has a research question or a hypothesis that they are going to be testing to see, yes, it works how often, yes, it works for which sampling population, yes, it could be generalized to the overall population. Whereas quantitative, you are generating a hypothesis. You're saying, based on observation, I hypothesize that this causes this. You're generating or coming up with a new hypothesis. Number 4, there's standardized measurements. Just like swimming and just like track and field, you have an objective measurement that you see with quantitative, whereas on qualitative, as already been said, is observations. It's subjective. By and large, if you are using time and measurement and scientific measurement, you're usually in the qualitative study realm, versus observation and opinion and subjective makes you qualitative. Number 5, the validity depends on the careful instrument construction. The instrument you use is critical. Has it been used before? Has it been validated? Is it good for this study? Is it the right instrument to measure what it says it's going to measure? Whereas number 5 on qualitative is the researcher is the instrument. The researcher's observation. You watch, you see, you watch the interaction, you set it up, you manipulate a variable, and so you are the instrument. That's a huge difference. The breadth, you have a limited set of variables in quantitative. Everything else is the same. You're changing one variable to get the impact of that one specific variable on the outcome. Whereas the trustworthiness in qualitative depends on the researcher's skill. Are you qualified to measure that skill? Are you measuring that same skill accurately every single time? Is it a skill that you have the authority to be the judge or not? You as the researcher are the validity of a qualitative study. Next is quantitative is large sample size. You can do it all. You can distribute, you can broadcast it, you can survey it, you can send it out large, and then generalize randomly to the overall population. Whereas qualitative studies, as you can see, are small samples. Since there's only one instrument and that one researcher is making the observations, you can't watch that in hundreds of people or thousands of people, where quantitative can send that out to thousands of people. Next is the testing and the verifying theories. A quantitative is testing. This theory is what it says. This theory measures what it says that it measures. It's valid, and we see it study after study. Multiple people at different locations can validate that this variable affects this outcome, and it does it in a statistically significant fashion. That's what quantitative research does. Qualitative, on the other hand, is discovering or exploring concepts. You're discovering what causes that. You generate the hypothesis. You're the one that comes to terms with that. And then finally, there are generalizations. With quantitative, because it's so big and so large, you make overall generalizations about the conclusions, how you analyze the data, how you report the data, if it's statistically significant for this population, and would that transfer to another particular population. Whereas it's extrapolations. When you're qualitative, you are extrapolating based on my observations. I deduct, or I would infer, that this variable does affect the outcome of how people interact, how people get burned out, how people continue to serve in that way. This is very important as we talk about quantitative, so that we know we're looking at something scientific, large people groups, that we're studying something that can be measurable and observed time and time again, that we're coming to a conclusion that can be generalized to the overall population. Those are all characteristics of quantitative research designs and methods. As we continue, we can see here that qualitative, mixed, and quantitative also have the way that the method is set up also differs. For example, quantitative, where this is the yellow because that's what we're focused on, is predetermined, whereas mixed has a little of each, but qualitative are emerging methods. So we're going with a predetermined method. It says it measures this. We're going to see if it measures this for this given sample size or this group or this location. Next is the instrument-based questions. You're basing questions on an instrument to see, does this question measure what it says that it's going to measure? Over here, this is very important with qualitative. You have open-ended questions. Open-ended question means that you could take all kinds of answers. Quantitative, you're going to answer 1 to 5. It's going to be on a scale. It's going to be A, B, C, or D. But qualitative, you can take someone's interview, their concept, their words. Remember, quantitative generates numbers. Qualitative generates words, a description. So open-ended will be important for that. When we talk about quantitative, when we're looking at research methods, we're looking at performance data. When we talk about qualitative, performance data, the attitude, and the observational data. You're gathering data and making an analysis based on numbers and based on facts, how they answered. Whereas over here, qualitative is interview data. You're interviewing, so when you're interviewing people, you're seeing observations, you're going to document that, audio, visual, what was there? Did they get nervous? Were they jittery? Did they look at the camera? Did they look away? You're reading body language. Qualitative, you are the instrument, remember. So it's very important to see the differences in those. And then when we look at qualitative, we're looking at statistical analysis. Is it statistically significant what the burnout ratio, or how they measured, or how they completed this task, or how long they stayed at this job, or what their training was? Is it statistically significant? Versus qualitative, you are looking at text and image analysis. You're looking at the images that were created. And finally, the statistical interpretation. What do now these statistics mean? Can we generalize something to the overall broader population based on what we see in this study? Qualitative generates numbers, it's validity, it's using a theory and proving the theory, using a theory to disprove another theory or make inferences to future studies. Qualitative, on the other hand, has themes or patterns. We can generalize that this happens with this group of people at this periodic, this regularity. It either happens, doesn't happen, when we look at all of those things. And then finally, you look at the approaches. What are the approaches when you look at that? So typically, when you look at qualitative approaches, they're constructive or transformative. They're knowledge-based versus quantitative that are postpositive or knowledge claims. We also say that qualitative have phenomenology, grounded theory, ethnology, case study, and narrative. We're going to be learning those design styles in the other group. So we're going to study today the qualitative designs, where we look at qualitative surveys, experiments, quasi-experiments, direct descriptive, and correlational studies today. And so we'll be looking at those as we continue. And then I'm going to go ahead and skip. That's more details about, I feel like we've covered that. I want to make sure that we have plenty of time to cover the others. But this is table 1.4 that shows you some research approaches, and this is in the Criswell and Criswell text. And I know that you all have that. It's also on Blackboard for us. But it's table 1.4, and it talks about the practices of the research and the researcher. Really good table here. I could just say that quantitatively, which is what we're going to talk about today, this is a summary chart. So quantitative tests and verifies theories, as we established. It identifies the variables. What is the thing we're going to change to see if that variable has an impact on the outcome? It repeats the variables either in a research question or a hypothesis, which we'll be discussing. It uses standards of validity, standardized test scores, standardized numbers based on historical data and future studies. It observes and measures numerically, generating accurate numbers based on the instrument. It is unbiased. So you don't want to have an influence on what you're measuring in any way. You want it to make it as neutral and unbiased as possible. And then you're going to employ statistical significance. All of these are important. And again, we see up here close-ended questions that we can determine that data from. So now when we look at research minders, qualitatively and quantitatively. The rest of our time, we're going to be studying quantitative research methods. These methods involve data collection, analysis and interpretation of that data, and the researcher's purpose for the study. All of those are quantifiable. We're going to generate that information. These research designs typically have an inquiry or an inductive, qualitative, mixed message approach that provides specific directions for people on how this research study is going to take place. So just a couple general reminders. Quantitative studies have four basic components or four assumptions when we look at all qualitative studies. Number one, rationalism. There's an internal source of the knowledge. What we mean by that is human beings can think and behave rationally. They have the ability and the capacity to answer the question, perform the skill, or do what it is we're asking them to do so that we can quantify a variable within that study. Secondly, empiricism. The investigation discovered through external sources obtained from experience and observation. So you're going to be producing empirical data. Data that has been collected in a valid and strategic instrument chosen that shows that we can measure what we're going to measure and the outcome for whatever variable we're looking at. We can say conclusively it does have an outcome or it does not have an outcome. Next, data collection and analysis. As we know for our dissertation, this will be critical in what we do. We'll have an advanced form of seeing and sensing what is called observation. And so when we look at quantitative things, we're going to be measuring numbers and observing those numbers. We can watch a race and see who wins. You could watch a swim meet and see who wins. You might not watch a gymnastics thing and know whether they quantitatively were able to perform that skill. That's more of a qualitative assessment. And finally, number 4 is observation. Systematically receiving knowledge from outside world through our senses or scientific tools or instruments that have been accurately validated to observe and make the observation quantitatively for what we are measuring. It's also a systematic recording of that info from data point to data point. Is there a time of the day that makes a difference? Does the male-female ratio make a difference? Does the climate make a difference? Like, you're controlling all of those other variables, only testing for one. There are 5 research designs of quantitative research for this class, or really in general. 5 different quantitative research designs. There's descriptive design, correlational design, experimental designs, quasi-experimental designs, and quantitative survey designs. Each of these have their own components. These are the 5 types of quantitative research designs. Let's take them one at a time. Number 1, descriptive designs. A quantitative study that's going to be giving us descriptions, a descriptive type test. Descriptive research analyzes the question, what is? Very important. You're describing. You see it, but what is it? You see it, but what causes it? You see it, how would you describe that? How would you objectively, not subjectively, describe that? A popular use of description research is to determine whether 2 or more groups differ on some variables of interest. The goal is to accurately and empirically, again, scientifically, numbers, not words, numbers, generate a scale, a system, a scientifically quantifiable description of the phenomena you are observing. Describes the differences between 1 or more variables in the selected group. Quantitative research design is a type of study that provides the direction studies. Others have called them strategies of inquiry. You're describing a strategy that you are seeing that those people are doing certain skills or have certain skills or there's an impact on them. Quantitative research questions inquire about the relationship among the variables that an investigator seeks to know how frequently these are used, and these are used often in social science. So research questions are used to find a discovery and to compare, versus a research hypothesis or hypotheses, which on the other hand are predictions. So the researcher guesses, makes an educated guess, a prediction, and then performs the experiment to say that prediction is true or based on accurate empirical data, that hypothesis is not true. Not for this population and not for other populations. So you're looking at whether you are actually having a research question and gathering data and making a conclusion, or you are testing an existing, already agreed upon theory to say your study further validates it and you're in agreement, or you have a study that even though that's the agreement, in this study, that did not hold true. You would say my hypothesis or the prediction counteracts or does not support the given hypothesis in that. The model for description questions says that they're going to look at a model here in example 7.7. There's a model for writing questions or a hypothesis based on writing descriptive questions. Again, this is the descriptive method. So you're going to describe something followed by inferential questions or hypothesis. You're going to draw inferences from a sample to a population. So you're going to see it and then draw a conclusion. In this model, the writer specifies descriptive questions in each independent and dependent variable and the important intervening or moderating of those variables. Are those variables linked? If you remove one, does the other one increase? If you remove one, does the other one decrease? Like, what is the relationship between the variables, or what is the relationship if you remove a variable? You're going to describe how removing that variable alters the study. And so when we look here, we can see that to illustrate this approach, a researcher wants to examine the relationship of critical thinking skills, an independent variable measured on an instrument, to student achievement, a dependent variable, in a science class for 8th graders, okay, a large metropolitan school district. The researcher moderates the assessment of critical thinking using prior grades as indicators in science classes and controls for the mediating influence of parents' educational attainment. Following is a proposed model. The research questions might be written. How do the students rate on critical thinking? So this is a descriptive question. What are the students' achievement levels? What are their grades? What are the students' prior grades in science previous to this? And finally, what is the educational attainment of the parents of these 8th graders? So you're going to evaluate past performance, current performance, parents, their influence. What did they attain? Now, that's just for this particular study. How much are the parents there? Do the parents help with science? Do they help with homework? There are other variables involved, but this study descriptively is describing the performance of 8th graders in science based on their parents' attainment of their own educational level, their attainment of their parents for 8th graders. Inferential questions. So now the next level. What do you infer based on that information? How does critical thinking rate to student achievement? The better they think critically, it should increase their performance. But we know that's not always the case. We know sometimes super bright kids are bored or they zone out. They're not. So because they're bright, they might not be a poor performer, but they may not be doing their homework, or they may not study, or they may not turn in their work. They may not go to class. And so we're looking at that criteria. How does critical thinking ability and prior grades influence student achievement? And how does critical thinking ability, so critical thinking at grades, relate to the student's achievement? Meditating the effects for educational attainment of the 8th graders' parents. So describing that phenomenon with an instrument, a rating, a valid. Quantitative, descriptive research. Correlational studies, on the other hand, they don't look at descriptive things or causation. They look at correlation. For example, you could say people who wear bright colors are generally happy people. Well, that might be true. Maybe they pick out bright colors because they're upbeat and happy, but bright colors and clothing They're not the cause of someone's happiness. They don't make them happy. They just happen to wear those colors. Versus causation, if you're looking at cardiovascular disease, we know that if you eat foods in high cholesterol, there's a causation that you could have an unhealthy heart. Or if you smoke, that lifestyle's choice could increase your chance of stroke or heart attack. So correlational studies don't identify causation, but instead look at correlation. When we look at correlation studies, another non-experimental is correlational design, in which investigators use correlational statistics to describe and measure the degree or the association or relationship between two or more variables, so more scores. These designs have been elaborated on more complex relationships among variables and techniques where the structural equation of modeling and hierarchical linear modeling and logistic progression. Again, looking at correlation. More recently, quantitative strategies have involved complex experiments with many variables and treatments like factorial designs and repeated measurement designs. Designs often employ longitudinal data collection over time to examine the development of ideas and trends. What's the correlation now versus 3 years ago, 5 years ago? What does that mean for the future? How does that correlate? Again, not causation, not what is the cause, but how does it correlate to past history and where we're going in the future? We see a lot of those designs. According to Criswell, in our book 2017, when it comes to quantitative research, it's important to understand variables and the types that are used in forming. A variable, which is what we're looking at correlationally, refers to a characteristic or an attribute of an individual or an organization that can be measured and observed, and that varies among the people or the organization being studied. For example, two variables associated with each other, which means that variable A is associated. It's related and associated to variable B. The result is a correlational hypothesis. While the variable A is the cause of variable B, we have a causal hypothesis that is best evaluated by a true experiment, which will be discussed later on. So a true experiment is what is the cause. Correlational is how are the factors or these variables related and what they do. For years, the ideas of Henry Blackbook, he was construct the meaning of causation and social research. He's one of the leader correlational study guys. And this thoughtful essay stated that the methods do not equate to causation. He talked about how the potential of lagged effects of understanding causation, variables that emerge over time and can be difficult to specify. He also called for making assumptions explicit and the causal mechanisms in experimental designs. With these points in mind, Blake called for more of a use of complex causal models to test important questions of social research. I'm going to skip the last, but I'll just go ahead. The researcher might be interested in evaluating whether playing violent video games is associated with, which would be causation, or rates the playground aggression in kids, which is a correlational hypothesis. So, in other words, video games is associated with higher rates of playground aggression, or it's correlational, that they could state that evaluated in a survey design. In another case, a researcher might be interested in evaluating whether the violent video games causes the aggressive behavior, and which a hypothesis would best be evaluated as a true experiment. So correlation is it's related, or true experiment, is it the cause or the causation? Experimental designs, number 3. And I know we're kind of short on time, so I'm going to kind of go through these quickly. But experimental designs. Quantitative methods involve a process of collecting, analyzing, and interpreting, and writing the results of a study. One of these methods is called experimental research designs, okay? So in experimental research designs, you have 5 things. You identify a sample population. You specify the type of design. You collect data and organize it. You present the results, and then you make an interpretation, and finally you write the research in a manner consistent with the experimental design of the study. Components of the experimental design are participants, They are the procedures, and they're the measures and the measurements. Most experimental designs include these three sequential designs. If more than one type of procedure is included, then that procedure and measure sections, they might combine those if you're looking at multiple procedures in one study. Experimental design systematically manipulates one or more of the variables. In experiential design, you're looking for causation. This causes this. You're testing a hypothesis to see does it cause or not. Importantly, an experiment isolates the effects by the manipulation, holding all of the other variables steady, solid. They are all constant. When one group receives the treatment, the other group does not, which is a manipulated variable. The experimenter can isolate whether or not the treatment then or the other factors influenced the outcome. Experiential design is what most of us think about. You have an idea and a hypothesis, you get a sample group, you test it, and then you report the data. And I know we're kind of short on time. Experimental design allows the researcher to make inferences about relationships among the variables, how they are all related together. This is another, I'm not going to go through the chart, but this is a chart in our book, in the Creswell book, table 8.4. These are questions if you're looking at experiential design, which I don't know because of being in the School of Divinity and most of us doing Christian leadership. I think most of our dissertations are going to be in the people orientation or qualitative. But if you're doing a quantitative or a mixed review, this is a great chart, a checklist of questions for experimental designs. True experimental designs, he also has on page 169 a test protest. So you have everybody, then you insert the variable, you manipulate the variable, and you do the test, pre-test and post-test. Another post-test only is everyone does the same thing together, no pre-test. Then you insert the variable, you manipulate one variable, and then you see, did the variable have an outcome on the group versus the control group that nothing was manipulated when all other variables remained the same. There's also a four-square group if you want to get into a deeper level, which is more complicated, but that is on page 169 in the text. Next, we have quasi-experimental designs. Quasi-experimental designs, as you would say, during the 19th and 20th century, strategies of inquiry, they wanted to study something, they wanted to look at an experiment with quantitative research were those that invoked post-positive worldview. And they originated mainly in psychology. So psychology, they wanted to look at these independent variables being manipulated for the outcome on someone's psyche or psychological experiment. It's often social experiments as well. These include true experiments and the less rigorous experiments called quasi-experiments. So what does quasi mean? Well, good question. Experimental research, if you look down here, it tells you that, experimental research seeks to determine if a specific treatment influences the outcome. So does this treatment, this variable, improve or disprove? Is it an advantage or disadvantage to this population group? The researcher assesses this by providing a specific treatment, one group withholding from another group, determining both groups are scored to an outcome. Experiments include true experiments with random assignment of subjects. Very important, quasi. Random, so it's randomly done to the treatment conditions, and quasi-experiments that use non-randomized assignments included with quasi-experiments are single subject designs. And so we can see there the difference in an experimental and a quasi-experimental. When we have this, when experimental studies, when you have quasi-experiments, the participants' levels of a manipulated variable of interest, so like a new treatment protocol or fractions with children, or you're measuring a second predictor in quasi that can be not manipulated. So it cannot be utilized random assignment. In other words, measuring whether or not the treatment are better for males or females. Do males or females learn fractions differently? Well, you might look at that, you might make a notice, but a quasi, you can't control if you're male or if you're female. And you can't control your exposure maybe to fractions. Designs in which a researcher has only partial or no control. So experiential, you have total control. Quasi-experiential, the researcher only has partial or no control over randomly assigning participants to the level of the manipulated variable. These are called quasi-experiments, and that's in the Criswell book on page 163. I'm not going to skip those for the sake of time, but you can look at those also on page 168. Look at those research designs. And finally, our last is survey designs. I hate to kind of rush. I don't really know where I am on time, but I feel like maybe I'm a tiny bit over. But research designs that involve surveys are very important. A lot of us in our dissertation may be utilizing surveys, so even though we're short on time, this is important information. A survey design provides quantitative description of trends. And leadership is definitely a trend. And leadership models have trends to them, as we all know and we're reading and discovering. Trends, attitudes, and opinions of a population or tests for associations among variables within a population or by studying a sample of that population. Survey designs help answer these questions. Descriptive questions. So what percentage of practicing nurses support the provision of hospital abortion services? Questions about relationships between variables. A survey can tell you how are these things related. Or questions about predictive relationships between variables. Does one endorsement support a hospital predict the other type of endorsement that you would receive? The design of a survey method follows a standard format. Numerous examples of this format appear in scholarly journals, especially in scientific journals. In preparing a design, these components into a proposal, consider the questions on the checklist shown above. Again, in the Criswell text, your survey has to measure accurately the variable that you are testing. Remember, this is quantitative, scientific. This question measures this outcome. This variable measures this outcome. Very important that your survey actually asks the questions in a non-biased manner and gives you the data that you need. So the survey design, we're going to skip that, but I'll just tell you that when you're looking at the survey design, you're going to be looking at the population and the sample. The population is the group in the study. The sampling is how you found that and how you're going to sample and what you're going to do. And then the type of sampling. It's the type of process, the participants in your sample. Ideally, you're going to draw a random sample. You want it to be cross-sectional so that you don't have a bias or the people group can't be generalized to the overall population. You're going to have stratification when you look at surveys, whether or not the study involves stratification of the populations before selecting that sample. What does that look like? Your sample size. How big? How small? What group? Where's it going to be? A worldwide sample, a regional sample, in the state sample, your own university sample. What is that sample size determination? And then the power analysis, how you're going to analyze the collected data, what you're going to be using, and what type of instrument that you're going to be using. The variables in the study, like we've already talked about in this video, although the reader's proposal, you learn about variables in the purpose statements and the research statements. It's useful in the methods section to relate the variables to the specific questions and the hypothesis on the instrument. In other words, how does the instrument answer your research questions or your hypothesis? So you want to validate that survey to prove you're collecting the data and that it's actual randomized data that can be given and then transferred those findings, either proving or disproving past historical studies or making an observation that could be carried forward for future research. There's variable research questions, and again, for the time, you're looking at variable 1 or variable 2, a control variable, that what you're trying to do with the survey, and you're looking at what questions. For example, if you have a research question, how many publications did the faculty member produce prior to the receipt of their doctorate exam? Then you could say questions 11, 12, 13, 14, and 15. And it says publication counts, it gives journal articles, books. So it shows how prior publications are measured, what questions on the instrument are asking that specifically, and then how those questions relate to the question and the variable that you're doing. So that's how you validate an instrument. Then you're going to take that data, as you know, you're going to analyze that data, looking for trends and relating that back, the survey, back to your research questions, back to the hypothesis, and then finally, you're going to interpret that research. You're going to give the interpretive, what does that research measure? What does that research mean? I'm going to interpret these results so that I can relate them back historically or moving forward. And the statistical significance. Is this a significant finding? Have we found something new? Have we statistically confirmed something that was thought of previously? So all research is critical. Qualitative, quantitative, mixed method. All research, we grow through research. We are either validating history, we are proving and observing today, or we are predicting what's moving on scientifically as we move forward, as you know. And so when you look at practical evidence, it includes the evidence size, how you can have a confidence interval, how confident you are, does it measure reliably what you said? And we just thank you for having the 5 opportunities. There are 5 quantitative methods, as we know: descriptive, correlational, experimental, quasi-experimental, and surveys. I know this was a lot. You're reading the Criswell and Criswell. I'm proud of you. It's been great for Marie and Jason and I to have this opportunity to gather this information, write these PowerPoints, and share this information with you. I wish you the very best in your doctorate. Thank you for all you're doing. It's been great. Again, I'm Keith Oglesby. It was great having this time with you.